These are the electronic configurations for chromium and copper. Have you noticed any unusual features in these electronic configurations? Yes, they did not follow Aufbau principle. How could this happen? Let's check out this video to find the answer. In this video, you are going to learn the anomalous electronic configurations of chromium and copper and the reason behind that. Stay tuned to find the answer. Chromium and copper has anomalous electronic configuration. What does it mean by anomalous? Anomalous means abnormal or ganjil. So, in this case, for both chromium and copper, there will be anomalous keganjilan in their electronic configurations. In what way does this anomalous occur in their electronic configuration? Let's check out the answer. Chromium and copper are the two elements in the D block having electron configuration which are inconsistent with the Aufbau principle, meaning that the electronic configuration of this copper and chromium does not follow the Aufbau principle. So the anomalies are explained on the basis that a completely filled or half-filled orbital is particularly more stable. So here we have the comparison between the expected electron configuration and actual electron configuration. This expected electron configuration is the one that follow or consistent with the Aufbau principle. Okay, meaning that we have to fill the 4s orbital first, later the 3d. But in actual electron configuration, this is the configuration that is inconsistent or did not follow Aufbau principle, okay, due to the reason to get more stable orbital. In this configuration, you can see that for the chromium, the actual configuration has 3d5, which has stability of half-filled orbital. Half-filled orbital here is more stable than this one, partially filled. And for the copper, it has this 3d10, which is completely filled orbital. So this orbital also is said to be more stable than the partially filled in this expected electron configuration. To see clearly the reason behind the anomalous electronic configurations of chromium, let us write the orbital diagram and SPDF notation for the expected electronic configuration. So for expected electron configuration is the one that consistent, that follow the Aufbau principle. Let's do this together. Now, we have 4 electrons in these 3d orbitals. So this kind of arrangement is said to be partially filled orbital. And this arrangement of partially filled orbital is not stable. So in order to form a more stable electron configuration, one electron in the 4s orbital will jump to the empty orbitals of 3d. And write your new configuration for the actual configuration. So this actual configuration is the one that inconsistent with the Aufbau principle. So now, by having 3d5 configuration with 5 electrons in parallel spin, so this configuration is called as half-filled orbital. So this half-filled orbital is more stable than the partially filled orbital. So this is the reason why the chromium will have anomalies in their electronic configurations. Okay, it is because to achieve the stability of the half-filled orbital. So to achieve stability, one electron from the 4s orbital occupies one of the 3d orbitals. Okay, so that's what we have done before. From this electron, 4s jump to the empty orbitals in 3d. In order to have a half-filled orbital, which is more stable than the partially filled orbital. So this is the main reason behind the anomalous electronic configuration of chromium. Okay, the main reason is to achieve stability of orbital. The same reason will be applied to this copper. So first, let's try to write electron configuration of the copper. So as you can see in the arrangement of the electron in this 3D orbital, we have 4 paired electrons, 4 elektron yang berpasangan, and 1 single electron here. So the existence of this single electron causing this arrangement to be called as partially filled orbital. And this partially filled orbital is highly unstable. So to make this arrangement to be stable than before, one electron in the 4s orbital will jump to the single electron in the 3d orbital and becoming a completely paired electrons. If you compare the arrangement here in expected configuration and the arrangement in the actual configuration, we can see that this arrangement has 5 paired electrons, 5 elektron yang berpasangan as compared to this arrangement. So in this kind of arrangement, we will call this one as completely filled orbital. And this completely filled orbital will be more stable than the partially filled orbital. So the reason is to achieve stability, one electron from the 4s orbital occupies one of the 3d orbitals. So from this electron here, we move to the 3d orbital. In order to have completely filled 3d orbital here, which is more stable than partially filled d orbital. So this completely filled orbital in actual electron configuration is more stable than the partially filled orbital in the expected electron configuration. So this is the reason of the anomaly electron configuration of the copper. The main reason is because to achieve the stability in their electronic configuration. So the actual configuration will be inconsistent with the Aufbau principle.
Thank you for watching everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning and remember, chemistry is easy and fun.